that's just life right now. So we are doing this homework sheet that is due on Monday. It is about division properties of exponents, and we are ready to go. Odds only, okay?
Are we doing the 9, like the things on top?
What?
Are we doing 9?
Yeah, everything. Everything that's odd. You guys ready? I know that the top of the worksheet says that.
Jared do it.
No, unless she wants me to, but
If you want to, you can.
I'm not as good.
Jared,
Okay, is it okay then?
Yeah,
Okay.
I'm just not as good as her though.
No, you're
So you
very
guys know.
good. All right. And just keep in mind that half of them have not had the lesson yet. So
Okay.
that's what, so we're like.
We're starting number 9.
Yeah, we're gonna do number 9. I know it says that it's due on Friday at the top, it's due on Monday. Slow things down a little bit.
Okay. So whenever, oh wait, have they learned this yet or?
No, so
Okay.
you kind of like really have to explain it.
All right. So whenever you have two numbers that have the same base and different exponents, and you're dividing them, the way you don't even have to mess with the numbers at all. You just have to mess with the exponents. So take the exponents, and if you're dividing, oh my God, that's awful. If you're dividing, you're just going to subtract the exponents. So this can actually be rewritten as 2 over 2 to the 7/3 minus 2. So you're just taking the 2 and you're subtracting them because you're dividing the numbers, okay? So 7/3 minus 2, how would we do that? What would you have to do first?
Track.
Yeah, but how would you make it so that you can subtract those numbers?
Put the 2 over 1.
2 over, yeah, okay. And then what?
5 over 2.
5. Wait,
What?
well, you can't subtract these yet because what's
You
missing?
make them alike.
Yes, you need them to have the same what?
Oh,
Denominator, perfect. So this needs a denominator of 3. So how do you turn a 1 into a 3?
Add the
Or multiply?
thingy that it has in common.
You just multiply it by 3. So you're going to multiply both by 3. And then 2 over 1 becomes 6. Yep, 6 over 3. So now we have 7 over 3 minus 6 over 3, which is what? 1 over 3. And then you have 2 to the 1/3. And then do you want them to simplify? That's it. That's just the answer, right?
Yeah.
Yes. So it's okay to have a fraction in the exponent as long as it's not negative. Okay, so if you ever have a negative exponent, you'll probably have to change something, but the moral of the story, whenever you're dividing numbers and they have the same base, so they both have 2 on the bottom, but they have different numbers up top, then you have to subtract.
Remember when we were doing multiplication with
Sorry,
same
Zach, I
bases,
hope you can see.
we would add
Oh wait, you're doing a good job.
the exponents. Now we're dividing the
It's like
bases,
that's
so we
why.
subtract the exponents. So multiplying, add the exponents, dividing, we subtract.
Okay, so this one, we're doing the same thing, it's just a little more complicated, but it's not so hard. So first we can work with the top and then we can work with the bottom. So like she was just talking about multiplying numbers that have the same base. What do you do with the exponents? What's that? You add them. Yeah, I probably worded it wrong. Basically, 5 to the second times 5 to the third, you can add these two exponents, 2 and 3. So the top is going to become what? 5 to the fifth, yes. And then the bottom is going to be the same thing. 3 plus 2 is also going to be 5 to the fifth. And these are the same thing. 5 to the fifth over 5 to the fifth is the same thing. Whenever you have the same number on the top and the bottom, what does it simplify to? 0? Not 0. 1, yes. Let's say I had like 3 over 3. Ignore the exponents, it's still the same number. 3 over 3, it simplifies to 1. 5 over 5, 5 to the fifth over 5 to the fifth is going to also simplify to 1. So, but they want to know what the exponent is here. So now we have 5 to the blank equals 1. So 5 to the blank is equal to 1. 0. Nice, Vicky. Anything to the power of 0 is going to be 1. So we simplified this. This all became 1. Okay, and then we had to figure out what the exponent is. So if you remember, 5 to the 0 is 5, anything to the 0 is just going to simplify to 1. So we had the 1, we just had to remember that it's 0 right there. Does that make sense? Okay, number 13. Same thing, sorta. It's just fractions now, but it's still just as easy. So, remind me, what are we gonna do? How are we gonna simplify this? We have the same base. They both have 9 on the bottom, but they have different things up top. And we're dividing them. So, what would we do with the exponents if the numbers are being divided?
That's a huge flip. Gosh.
Not multiply them, you have to subtract them. It's the same thing as here. So whenever you're, I know you would. 9 to the 3/4 divided by 9 to the 1/4, you can just subtract the exponents since they both have 9 on the bottom, okay? Whenever you're dividing the numbers, you're subtracting the exponents. So you have 9 to the 3/4 minus 1/4. What's 3/4 minus 1/4? 2/4, which simplifies to 1/2. So your answer is 9 to the 1/2. Remember, you're just subtracting the exponents. Let me know if you want to take over.
I kind of do want to.
What was the answer?
I don't know. Do you think I'm doing it?
You're doing great.
What was the answer, Jared?
The answer was 9 to the 1/2. Okay, I'll just do this last one.
Okay.
Okay, same thing. Ignore the fact that it's a letter. They have the same base. Okay, the base is n in both cases. But we're dividing, so what are we going to do with the exponents? Subtract. Whoever said subtract. Yeah, nice try. That's good. Okay, so we have n to the -1 minus -4. So what is it? How do we do this? Subtracting a negative, what does it become? Positive. Yeah. Perfect. Is that what you do?
Yeah,
We learned it a different way.
Chillicothe shape design. That's what my 6th grade teacher taught me, and I always say it like that.
Oh, really? Okay. And -1 plus 4, what's -1 plus 4? 3, perfect. And if you're ever confused, it's just 4 minus 1. So n to the 3rd is your answer. Okay, Miss Leg's gonna take over.
You get a well-deserved break. Good
Yes.
job. Okay. All right, number 17. Let me make it a little bit bigger. I can't. It's just so hard because the exponents are so tiny, especially when they're fractions. It's like so hard to see. Okay, so I get an easy one. 11 x to the 11th times y to the 3rd over x to the 11th. Hey, isn't that the same thing in the numerator? They're looking at me like, can Jared teach us again?
No, and then.
Hey, that's the same thing as in the numerator. What does that equal?
0.
Not 0. Technically, the exponent would be 0 because 11 minus 11 is 0, so that would be x to the 0 power, which is 1. And that's so all true. But just like we would recognize that any number over itself will equal 1, any term over itself, x to the 11th over x to the 11th, that equals 1 also. So we can just cancel it out. And actually, I didn't notice this when I first looked at this problem. I would have solved it the exact same way, adding the exponents. But then when I looked at it, I was like, hey, wait a second. Yeah, if you just switch these commutative property of multiplication switchies, it literally would be the same thing. So when you see a problem like that, you can get it done lickety split. All right, so this is gone. Not gone, it equals 1, but since we have other terms here, it's gone. Y to the 3rd over y to the first power, good. 1 is fine. And then what would we do with our exponents? Subtract. Remember, I'll write it at the top because I know it's new for some of you. So when you're multiplying bases, you add exponents. Write this down. When you are dividing bases, you subtract your exponents. Those are the quick tools in your toolbox.
Write this down first.
Yes, but it's okay. Writing it down again is just good practice. So when we subtract our exponents, we get y to the 3 minus 1, which is
Oh no,
y squared. Are we done?
yeah.
Yes, we are. All right, let's do 19.
Miss Lou,
Yeah.
I just wrote all this.
Is that for Spanish?
Yeah, this is Spanish.
If you need any help with your geometry, you want to get a head start in your homework. I saw that she said you could start your homework next week.
Well, that's for the next week. I want to really remind you.
Oh, you haven't learned that lesson yet. How did you do on your? Are you allowed to do corrections?
Yeah, I think so. As long as you turn in your paper.
Why don't you ask Jared for help on the corrections?
Well,
you guys can work
I don't know yet. She hasn't said anything about corrections. She said if you turn in your paper and like I see where you went wrong, then you can do corrections on that problem.
Oh, okay. I would just, why don't you work with Jared and just work on the corrections? I can talk to her and see if she'll allow it. And then also it'll help you study for the test. You know what I mean? Do you have anything else to do right now?
Mm-hmm.
Exactly. Go work with Jared on his quick corrections. Bye. You can take your Mickey Mouse pants and get out of here. Yeah, but
It is not
it's
very
good for you. All right, number 19.
How does he get to go up there? Oh my god. Easy geometry.
10n to the 6th times n to the 3rd over 5n to the 2nd times n to the 7th.
I'll go there.
Okay.
Oh, you want to just sit there? Okay. He doesn't want to leave. He just wants to be with us. You can go out into the main area if you want to.
Jared, that's up to you.
What? I really don't care.
Okay.
Neither do I.
Why don't you guys go out there so that you can talk and not worry about
Yeah, that's
talking while we're filming, okay? So, what is the first thing we can take care of here? It's super easy. What is the first thing that we can take care of here?
Exponents.
No, we don't need to touch those exponents yet. What is the first thing that can be simplified to get it out of the way? What do you guys see here that looks just kind of like a regular fraction that you would normally see that can be simplified? 10 over 5, right? So we can divide those, right? What's 10 divided by 5? 2. So 2 is going to go in our numerator. Now we have m to the 6th divided by m to the 2nd. What do we do with our exponents?
We subtract.
Subtract. So we have m to the
Fourth power.
4th power. Now we have n cubed over n to the 7th power. What do we do with our exponents? What do we get? Not 5. Negative 4. So n to the negative 4. Are we done?
Yeah.
No.
No.
What do we do?
Oh, subtract and add.
These are not the same base.
Oh no, put them together, send it to the base.
Yes, this exponent has a negative attitude. We have to send it to the basement. So our numerator is going to stay 2m to the 4th, but this guy has got to go down to the basement to get a more positive attitude. So we have 2n to the 4th over n to the 4th. All right, number 21. Let's take it one part at a time. 3 squared over 3 to the 5th. What do we do with our exponents? Subtract. So that would be 3 to the negative third power. Very good. Let's keep going. Don't send anything downstairs or upstairs yet. Let's go all the way through and then we'll deal with punishing the negative attitudes, okay? M to the 5th over M to the 7th. What is it?
-2.
Good. M to the negative 2 power. And then T to the 6th over T to the negative 5th. That's something that we'll have to write out, right? That would be T to the 6th minus -5, which would be what? Kill the cockroach, change the sign, what is it?
It's 11.
T to the 11th. Are we done?
Yes. No, we
No.
have to send them to the.
Yes. So there are 2 parts that need to get sent to the basement, right? This can stay in the numerator. So I'm going to rewrite this so that T to the 11th is going to be in the numerator, and then 3 to the negative third goes downstairs to get a more positive attitude, and then M to the negative 2nd goes downstairs to get a more positive attitude. Are we done?
Yep.
One more tiny thing to do. We just have to cube the 3,
What?
because that can be simplified. 3 times 3 times 3, and you can do it in your calculator if you want. It's 27.
Come on, where did you change? How did you get 27? The
3 cubed. 3 times 3 is 9. 9 times 3 is 27.
Oh, so why did you have to do that?
Because the 3 ended up with an exponent of -3, which became positive when we moved it down. So we just have to simplify. 3 cubed, we actually have to do the math for that. 3 times 3 times 3. Like these are letters, so I can't simplify them anymore. But a number that is raised to a power can be mathed.
But if it, so if there's like any number, like you have to do that?
Yeah,
Oh, okay. Are you gonna count the answer wrong and forget to do that?
I'd probably give you like partial credit. Like if you gave me this instead of this, and let's say the questions are worth 5 points each, I'd probably only take 1 point off out of that 5. All right, number 23. Woo, this is a doozy. We got all it is and all it is. Let's start with our coefficients. 12 divided by 4 is 3. Then we have a to the -1 over a to the 5th. So that would be a to the -1 minus 5, which is what?
4.
Kill a cockroach, change the sign, -6. So we have a to the -6. Leave it there for now. Let's get everything down and then we'll punish the negative attitudes, okay? B to the 6 over b to the -1. Let's subtract b to the 6 minus -1. Kill the cockroach, change the sign. What is that?
7.
B to the 7th. So we'll put that up here. Everything's staying in the numerator for now. Then we will punish the negative attitudes. C to the -3rd over c to the 5th. C to the -3rd minus 5. Kill the cockroach, change the sign, and that's c to the -8. Are we done?
No.
What do we do? Yep.
Now could the 3 stay?
The 3 stays
Okay.
because it is not, even though it's like next to, it's all buddied up with the A, it's not a part of it's not a part of this operation. This exponent operation is only affecting the A because in order of operations, exponents comes first. So this can't be together until this is simplified, and that means that we're gonna have to move this to the basement. So I'm gonna rewrite this so that the 3 can stay. The a to the 6 has to go in the basement to get a more positive attitude. Can this stay or does it need to go? Stay in the numerator. Stay or go?
Go.
Go. So c to the positive 8 will go in the denominator.
Have you done that?
No, to do all the rest of them. Gotta get into that scientific notation, bro. What? This one?
No, bottom.
Oh, scientific notation?
Yeah, because they're like, when I get water,
I'll show it.
they're like open.
Yes, they are. We're, it's okay. We're just going to apply the tools from our toolbox from today, the scientific notation. You can go ahead and go.
I don't know if you're doing this.
I was saying yes to you, girl. Right, now we got this beautiful scientific notation.
Oh, yeah. Oh, wait.
All right. Number 25. We're going to do the same rules that we just did. We're going to divide our numbers, and then with our same bases, we're going to subtract our exponents. So first things first, 3.6 divided by 9. Is that 0.4? Let's see. 3.6 divided by 9 is 0.4. Times 10 to the negative 10 minus negative 6. So 10 to the negative 10 minus negative 6. Do you guys understand why I wrote it like that? Because here are numbers negative 10 and negative 6. They have to be subtracted. Negative 10 minus negative 6. Kill that cockroach, change the sign, and we get what?
Negative. You're going to get the negative.
Negative 4, and that's okay. So we have 0.4 times 10 to the negative 4 power. For my people that did not have my class yet today, you don't have to worry about having no idea what I'm about to talk about. The people who did have my class, basically Callie and Ricky right now, I want you guys to answer this question for me, okay? This answer, there is nothing wrong with the value. This value is correct.
No.
I'm going to show you that the value is correct, the actual value. The way it's written is not okay, but the value is correct. And I'm going to show you, I'm just going to write it in standard form. So if this is to the negative 4 power, what does that really mean? It's not 0.4. It means that I have to go to the left 4 places, right? 1, 2, 3, 4. And this is the actual number in standard notation, so 0.00004 is the actual value. We're going to write it in standard notation as an answer, but I just wanted to look at my we're going to write it in scientific notation, but I am going to write it in standard notation just so I can see the number, okay? Can somebody from my first period class tell me why this isn't in proper scientific notation? Exactly, because the ones place doesn't exist right now. In order to make this have a ones place, the decimal needs to be over here. But if I change this to the whole number 4, the exponent negative 4 will no longer be accurate. Very good. Because if I move this decimal here, I have to represent that place value in my exponent. So what I have to do is say, okay, this isn't really the whole number 4. It really is over here, which means I would have to move it to the left once. Moving it to the left, is that adding a place value or subtracting? It's subtracting, right? So it's moving to the left. So I would be having a negative 4, and then I would have to take away one place value, kill the cockroach, change the sign, And Ricky, you said it's gonna be a -5. And if I write that in standard notation, I take my 4, my whole number 4, and I say, oh, -5 means I go to the left 5 times. 1, 2, 3, 4, 5. Is this the same number as that?
Yep.
Good. Then is this the same value as this?
Oh, yeah.
No.
Yes. Because 0.4 to the times 10 to the -4th power, 0.4 were the decimals here, and we moved it to the left 4 places, 1, 2, 3, 4. It was already on this side of the 4. Here, it's the whole number 4, so it needs to move an extra place, and then those 4 places, so that's why it's -5. Does that make sense? So even though this is the right value, this is the correct notation. Notation is the way we notate or write it. Does that make sense?
Nope.
Let's do number 27 so we can practice again. Okay, the easy part. 8.4 divided by 2. 8.4 divided by 2 is 4.2, yay. Oh, you know what I love about that? It's already in proper scientific notation because there's a ones place and the rest decimals, right? So we're not gonna have to do all that crazy stuff that we did before. All right, then we have 10 to the -5th over 10 to the -8. What do we do with our exponents? Subtract them. -5 minus -8. Kill the cockroach, change the sign. What do we get?
3.
+3. So we have times 10 to the +3 power. Is this correct scientific notation? Yes. This is good, so we don't have to adjust anything. I love when they're like that.
I don't know.
I got it. What's up? Okay. Bye. All right, number 29, last one, guys. Woo! We are cooking with gas here. Number 29. Somebody do it on your calculator. 3.5 divided by 5. 0.7 times 10 to the 6th over 10 to the 8th. 6 minus 8 would be -2, so it would be times 10 to the -2 power. Is this in proper scientific notation?
No.
I heard no's and yes.
No, because it doesn't have one place.
Good.
It needs a one place. And then.
Is this the correct value? Is it?
Yes.
Yeah, we did it correctly. So this value, 0.7 times 10 to the -2. Yeah, let me write it in standard notation and you'll see I'll match it up with the other one. So 0.7 to the -2 power means I would need to take 0.7 and take the decimal and move it 2 places to the left. 1, 2, and then it would be 0.007. That is standard notation, which just means a regular number. And then let's turn this into proper scientific notation and then make sure that the standard notation also matches, okay? So 0.7 times 2 to the -2 power is not gonna work. What will work for this number, for scientific notation? 7. Are you a science guy? Do you like science? Okay, because you're really good at this. Okay. So 7, and the decimals here, although you don't have to show the decimal when it's a whole number, times 10. Now I'm gonna put a blank, okay? I know you wanna say it, but I'm teaching, okay? So times 10 to the blank power.
Can it be positive or -1?
Let's see what happens. in order to represent this exponent properly, I need to say, well, this really was in a different spot before. So to get it back to the original, I would have to move it to the left once. Is that adding a place value or subtracting? Subtracting. So it would be -2 minus 1. Kill the cockroach, change the sign. So it'd be -3. And I can prove that in standard notation, same exact number. The number 7, the whole number 7, moved 3 places to the left, 1, 2, 3, is 0.007. 007. Isn't that like a James Bond thing? So which one of these is the way that we're gonna write our answer? Choice 1 or choice 2? Choice 2. They're both the correct value. We have proven that, writing them out in standard notation. But this one is an actual proper scientific notation. This one is faking it. It's like, hey, look at me, I'm a scientific notation. I got a power of 10 right here, times 10 to -2, I'm good. No, this is proper scientific notation. We good?
Wait, okay.
I want to erase it, but that's it. That was an easy homework. Or, I wouldn't say easy, I just mean we got through it pretty quickly.